Welcome to the deep dive. We're here to cut through the noise, get you informed quickly, and maybe find a few surprises along the way. Look, if you're like us, you want to understand the big shifts in AI, right? But without getting buried in jargon. You want those moments where it just clicks. Well, today we've got something pretty revolutionary on the table. We're talking DINOv3. It's a new development from Meta, and they're calling it self-supervised learning for vision at unprecedented scale. That phrase alone, unprecedented scale. It really makes you think, doesn't it? Hints at a big change in how AI actually sees here. So, our mission today, simple. Pull out the key stuff. What is DINOv3? How does it work? And what could it actually mean for all of us?
And yeah, that phrase unprecedented scale, it's not just marketing talk. This isn't just another small step, another update. It feels more foundational, actually. It's like a different way of thinking about how AI gets visual information, almost like teaching it grammar instead of just vocabulary lists.
Yeah. Okay, let's unpack that. Because self-supervised learning for vision sounds impressive. But for those of us following AI, what makes DINOv3 stand out? What's different about its approach?
Right. So DINOv3 is Meta's latest big push in self-supervised learning for computer vision specifically. Now, self-supervised learning itself, the basic idea, isn't brand new. It's about AI learning from data without needing humans to label everything. Traditionally, people use clever tricks like hiding part of an image and making the AI guess what's missing, or rotating it, making it guess the angle, that sort of thing. DINOv3 takes this quite a bit further. It refines it significantly. It builds on something called self-distillation, using vision transformers. Essentially, you create slightly different views of the same image. Maybe one's cropped, one has different colors, and then you train a student network to see those views in a way that's consistent with what a more powerful teacher network sees. And the teacher network, it keeps improving based on how the student does. So nobody says that's a cat, but the AI figures out what's fundamentally important about catness just by comparing these different views. It's incredibly efficient. A powerful way for the AI to teach itself.
That makes sense, sort of bypassing that huge bottleneck of labeling everything. And you mentioned unprecedented scale again. You talked about efficiency, but what does scale really mean here in terms of capability, especially when they claim it produces our strongest universal vision backbones?
Yeah, the scale isn't just the sheer amount of data, although that's huge too. It's also about the complexity of what it learns from that data. Much deeper patterns than before, without needing all that human guidance and that output. Universal vision backbones, that's the core idea. Think of a backbone like the AI's visual cortex. It's the fundamental part that pulls meaning out of raw pixels. And universal means these backbones are so robust, so general, that you can take them and apply them to almost any vision task. Object recognition, medical scans, even satellite data analysis. And you can do it with minimal extra training.
Minimal extra training.
Exactly. Normally, you'd need very specialized models for different things. DINOv3 offers this single, powerful starting point. It's like it gives the AI that visual grammar we talked about, not just specific words.
That sounds almost, too good to be true sometimes. Are there limits? I mean, are there specific situations where even these universal backbones might struggle, or where a really specialized model still wins out?
That's a really good question. And yes, of course, there are always nuances. It's still evolving tech. So for extremely niche areas, maybe with super abstract visuals or where you need incredibly subtle domain-specific context, a model trained purely on tons of that specific labeled data might still edge it out slightly in performance.
Oh, okay.
But DINOv3 closes that gap dramatically. It makes it a fantastic, often better starting point for nearly anything visual. And it really lowers the barrier. You don't always need that massive specialized training effort anymore.
Right. That context on universal backbones is key. It really shifts the perspective.
Okay.
So if it's learning on its own at this huge scale, how does it get such a powerful understanding? The research mentions these rich, dense image features. What's so special about those features?
Yeah, those rich, dense features are basically the detailed, meaningful bits of information the AI pulls from images. Very granular. It's not just seeing car. It's understanding the little parts, the textures, the context, how they all fit together. What makes DINOv3's features really stand out, according to Meta, is their impressive self-similarities and exceptional consistency in time.
Consistency in time, meaning like in videos.
Exactly. Picture a car driving down a street in a video, or someone walking. Older models might kind of lose track, or their understanding might flicker as the perspective changes, or something briefly blocks the view. DINOv3's features mean the AI holds onto a stable, consistent idea of that object. It knows it's the same car, same person, even as it moves, changes slightly, goes through different lighting. That consistency is absolutely vital for understanding dynamic, real-world scenes.
Okay, here's where I thought it got really interesting. The research also says these dense features are aligned across objects and even across dramatic style changes. Dramatic style changes. That's a bold claim. Can you give an example? What does that actually mean?
Absolutely. And it is bold. Think about how we see things. You can recognize, say, your pet dog, whether you see a photo, a cartoon version, or even a kid's scribbly drawing of it, right?
Yeah, of course.
Our brains abstract the dogness. But traditionally, AI really struggles with that. If you only train it on realistic photos, showing it a Picasso-style painting or a simple line drawing of the same thing would completely throw it off. It just sees different patterns.
You're right. It wouldn't connect them.
Exactly.
Yeah.
But DINOv3's ability to align features across these styles means it can make that connection. You can recognize the object, whether it's a photo or a sketch or something highly stylized. It bridges the gap.
Wow.
It suggests the AI is moving beyond just matching superficial patterns. It's getting closer to a more abstract, conceptual understanding, more like us.
So the potential there is huge. Less data needed, maybe.
Potentially, yes. It implies you could teach an AI a concept with just a few examples, maybe real photos, and it could then apply that understanding in wildly different visual contexts. Think about domains where getting labeled data is really hard or expensive. This could radically speed things up. It's a major step towards, well, true visual intelligence.
That's incredibly powerful, that idea of understanding concepts across different looks. So, okay, we have these amazing features, consistent, handle style changes. What can you actually do with DINOv3? The paper mentions applications needing just a few manual annotations.